This is lesson 5 of geometry, and today's lesson is about figures that are congruent, and figures that are similar, figures that are congruent or similar. And we're also going to be taking a look at some things that we've talked about. We're going to do a little review. We've talked about many different things in geometry, and so today's lesson is going to be quite simple about congruent and similar figures, and so we'll also talk about the things that we have learned so far. We're starting with lines. You recall a line is a series of points that go on in both directions. Here we have a line. I'll pull that word over here. A line, a series of points that goes in both directions. We also talked about a line segment that has a starting point and a stopping point. And then we also talked about a ray, which has a starting point but goes on forever in one direction. We also talked about angles. Two rays make an angle, and this ray, these two rays, make an acute angle. So we've got some angles here. All of these are angles. This is an angle, and here's an angle, but this one here is an acute angle. This next one is a right angle. Remember, we have that little piece of paper that fits in a corner. It's 90 degrees. That's called a right angle. And this one that's more than 90 degrees is called an obtuse angle. We remember that. Next, we'll take a look at polygons, circles, and vertices. With polygons, you remember that they have to be closed figures, they are flat, and they have straight sides. If you could take a look at the figures that we have here, we have some that are closed, some that are flat, some that are straight sides, and some that are not. There's one here that is not a polygon. This one here, this one right here, is not a polygon, of course, because it is a circle. So we've got a couple of the word circles up here too. The next word, vertices, remember that is plural for the word vertex, and that is where two or more lines come together. That's called the vertex or vertice. And if you look at this figure here, it's got 1, 2, 3, 4, 5, 6, 7, 8 vertices. And notice that the sides, 1, 2, 3, 4, 5, 6, 7, 8, the sides go along with the vertices. So that was our polygons. Next, we're taking a look at triangles. We talked about several different triangles, actually 4 different triangles. We've got a right triangle, and that's the one that has the right angle in it. We mentioned that. And an isosceles triangle has 2 sides that are the same length. And notice I indicated that. I'll put some 2 black marks on there that tell us that those 2 sides are the same. The next one we had talked about was the equilateral triangle. I'm going to use red this time. This side and this side and this side are all the same, so I used all the same marking. And then the scalene triangle is a triangle that has different size sides. This side marked with green is longer than this side, and then I put 2 marks there because it's different. And oh, this side is different yet, so I'm going to put 3 marks there. So we've talked about 4 different triangles. Now that we've completed our review of the things that we've been talking about so far in geometry, today's lesson talks about congruent figures and similar figures, and we're going to start with congruent. Figures that are the same shape and the same size are called congruent. Well, we've got 2 figures here that we're going to just slide one on top of the other. They are the same shape and they are the same size, so they are congruent. Here is another set of figures. Slide one on top of the other, and you'll notice they're exactly the same size and the same shape. So they are also congruent. And the last figures, and you can see by looking at those, if I slide one on top of the other, same shape, same size, and once again, they are what is called in mathematics congruent. So we have some congruent figures. Here we have a figure that has 6 vertices and 6 sides. And this one has 6 vertices and 6 sides. It's called a hexagon. They are the same shape, but they are not the same size. If they are the same shape, they're said to be similar. But if they're different size, well, then we'd say that they're similar. They're not congruent, but they're very close. They're similar. The next figures, we have an oval, and these are different sizes, but they're the same shape. They are similar. And the last set of figures are two triangles, two isosceles triangles, and they are similar, but they are not congruent. They're the same shape, but not the same size. Here we have a four-sided figure we recognize, of course, as the square, each side being the same length in the square all the way around. Here we've got our friend, the rhombus, and these are also the same size sides. The sides are all the same, but this figure, the square, is not the same shape or size, so they're not congruent or similar. And also, the bottom figure, I know they're both triangles, but we've got an isosceles triangle, these two sides are the same, and a right triangle. They're not the same shape or the same size, and so they're neither congruent nor similar. Now, let's take our exercise just a little bit further and ask you to draw a figure that would be congruent to the figure that's given there. Well, if we look at this first figure here, we've got our rectangle, and if we take a look at the number of dots, 1, 2, 3, 4. So we're going to draw something that is 4 dots wide. 1, 2, 3, 4. And let's count the dots going up. We've got 1, 2, 3, 4, 5, 6 dots high. So let's see, we've got 1, 2, 3, 4, 5, 6. Oh, and I can see too with my eye that that's the same height as that one. And I'm going to go over and down and finish off my closed polygon here. And there is a congruent figure. It is the same shape and same size as the one that they gave us. Let's take a look at this triangle next. We've got 1, 2, 3 dots. So I'm going to draw a line. It's got 3 dots. 1, 2, 3, and 1. Let's see. We got 1, 2, 3, 4. Oh, it's 4 dots tall, but it goes to this dot here. So 4 dots down, but it has to meet at this point. So now I've got two figures. These two are congruent, and these two are congruent. On to the next slide. What we want to try to draw here is a figure that is similar. So it has to be the same shape, but it has to be a different size. Well, let's count the dots. We got 1, 2, 3. I'm going to make it twice as big, so I'm going to use 6 dots. 1, 2, 3, 4, 5, 6. Well, if I went twice as big on the top, I'm going to have to go twice, and at 1, 2 dots here on the side, so I'm going to make that into 4. 1, 2, 3, 4, and 1, 2 dots in, 1, 2, 3, 4 dots in, 1, 2 dots down, so make that into 4. 1, 2, 3, 4 down, and 1, 2 dots over, so I'll make that into 4. And 1, 2, 3, oh, that must be 6. 1, 2, 3, 4, 5, 6. Mr. F, you made a mistake. Let's see what's wrong here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 7. On this slide, I'm going to draw a figure that is similar to the one that's given here. Before I start, I'm going to take a look at the line segments across the top here. I've got one line segment there, dot to dot, and here's another line segment. So I've got 2 line segments there. And I'm going to draw a figure that's similar but bigger, and I'm going to make it twice as big. So if I had 2 line segments across the top, I'm going to have now 2 times 2 is 4. So 1, 2, 3, 4 line segments. And if I look down the side, here's 1 line segment times 2. So I'm going to make that 2 line segments. 1, 2. And here's 1 line segment from there to there. And I'm going to take that times 2. 1 times 2 is 2. There's 2 line segments. Looking down, and another line segment. 1 line segment times 2 is 2. 1, 2. One line segment again is again 2 line segments. And here we have 1 line segment, 2 line segments. 2 times 2 is 4. 1, 2, 3, 4. And right back to the beginning here is my similar figure for the one that was given. I'm going to try that again, and I'm going to try to make it 3 times as big. So if I still have 1, 2 line segments, 2 times 3 is 6. I'm going to try this and see if it works out. 1, 2, 3, 4, 5, 6. 1 line segment here times 3. 1, 2, 3. 1 line segment here. Another 3. 1, 2, 3. 1 line segment, 2, 3, yeah. And let's see, there's 1 line segment going down, so I'll make that 3. 1, 2, 3. 1 line segment across the bottom, and that's 1, 2, 3. And then 2 line segments up, and let's see, 1, 2, 3, 4, 5, 6. That's right. And I'm there. I made it 3 times as big. This one's